Google. Now we're going to switch gears into a technical discussion on building for the future and really scalable AI. So I'm delighted to welcome to the stage Chelsea Chop, product manager at Google Cloud, along with representatives from Owl.ai, SandboxAQ, Baseten, and Palo Alto Networks. Thank you.
Am I live? I'm not.
I think we're all live.
Am I live? Can you hear me?
I'm in there.
Okay. Hi. Hello.
Well, good morning, everybody. Thanks for hanging in here. We'll try to keep it brief and snappy because I know lunch is after us, and I know that's probably one of the more exciting things.
We've already lost them. They're gone. They're just food.
I mean, they are here, so
Okay, that's
might as
true.
well start. But it's exciting for me to not have to walk through what AI hypercomputer is, and I hope that you all feel a little inspired about what you've heard and how everything kind of works together. And it's not just the hardware, but it takes the hardware, the software, the flexible consumption models, and the AI that you build on top. It all needs to come together to be able to power these new and unique experiences. So I'm really excited about the panel we have here today. We have a wide range of companies to kind of talk through how they're using all these components to be able to deliver new experiences for their users. So I'm going to have them each briefly introduce themselves, talk a little bit about what their company does very quickly, and then I sprung this on them. I asked them to provide a little fun fact or something that's not on LinkedIn. So sorry.
It's okay. Hi. So my name is Antonio. I am the CTO of Owl AI. Our journey is wild over the last couple of months. So I'm actually a Zoogler. So I used to work at Google. I was at Google for a long time. And my co-founder was also at Google for a very long time.
He was my manager for a while.
Yeah. We had like this crazy adventure. Sergey, like the co-founder of Google, was like, "Oh, you should go build a company off of this tech that you guys are working on." And we ended up just doing this thing. Like, "Okay, Sergey, whatever you say." It's been a crazy thing. But we're a sports intelligence company, so we're building out intelligence on understanding sports, right, in a little bit more fundamental way. And it has been wild. Like the idea of there's so much wrong with officiating sports, and like you think about when you watch a game and you're like, that's a bullshit call. Like you get angry at the TV, right? Like just like fixing like a lot of those problems in every sport, like soccer, rugby, football, everything, right? So that has been a wild thing. Fun fact, I'm a gigantic nerd in case it isn't clear immediately. But I'm also like some big video game guy. I have been like my whole life. It's been like this outlet for me. And I like 15 years ago, I wrote this add-on for a very popular game called World of Warcraft. And I'm big fan of the game. And it's like you write UI add-ons and all this stuff. It kind of has become a global phenomenon, and I didn't really so I have 500,000 users that I support like in my free time, and like I have a Discord server with like thousands of people. So like when I'm done like with work for the day, which I stopped working at like 11 o'clock at night because I'm like, okay, I need to stop. And then I like switch over to like my gaming PC, and then I'm working there and I'm writing code there. And the interesting is using this new technology, things that used to take me like days or weeks, like writing like new abstract syntax trees for like this new search engine that I'm writing inside of the game, all this stuff is now taking me like minutes. It's not it's wild how much faster I'm able to do that. And then I take those learnings and then I apply them back to our company. And I'm like, oh yeah, look, all this stuff that I did over here, let's apply it over here. It's this virtuous circle stuff. So yeah.
It's a good practice arena.
Yeah.
Arman, do you want to introduce yourself?
Absolutely. Thanks, Chelsea. So hello, everyone. I'm Arman Zaribafiyan, Head of Strategic Alliances at SandboxAQ. My background is in computer engineering, but for the last decade or so, I got the entrepreneurial bug and have been like building startups, growing startups, building products.
High five, buddy. Yes.
Yes. And my last startup was acquired by Google X, which then turned into SandboxAQ that was spun out of Google. So we share some of that background in terms of like Sergey and Eric working together and thinking of like, oh, we should build a company out of this. And Sandbox was born out of Google X or Moonshot Factory, basically. Sandbox is an AI for enterprise company. So we build basically large frontier models that are domain specific. And I'm going to tell you a little bit more about that just to unpack that. We basically call them LQMs. We build large quantitative models. And this is to directly contrast with LLMs that are trained on large language, basically language data and text-based data. And the focus is that one of the example areas that we are very excited about and we're working on with companies like large pharma, like Sanofi and oncology on different, basically, essentially curing diseases and finding new drugs, better drugs. And when you want to cure cancer, you can't just rely on LLMs and ask that question, because if the LLM is able to answer that, that means that somewhere in Stack Overflow, someone had found a solution to brain cancer or different types of disease, which is not the case. So while LLMs are super exciting and super useful, and they basically started a new paradigm, there are specific areas and problems that require domain-specific models that are trained on quantitative data, physics, and chemistry of these molecular interactions to be able to predict properties and to be able to essentially design new drugs. So this is what we do. We work with large pharma, we work with different enterprises and helping them accelerate scientific discovery using these domain-specific frontier models that I'm happy to share more details about. But for us, our entire workflow and process is on cloud. So Google Cloud is kind of like a one-stop shop for all our computing needs. It's kind of like full circle. Because these models are physics-based, we generate our own data on the cloud, and then we train models on that data, and then we serve those models, and then these models make predictions that then help us get insights into running more simulations and running better simulations and generating more data. So it's kind of like a full circle end-to-end cloud-based process. And for that reason, I'm really excited to be here and share some of those experiences with the audience.
And one fun fact, I'm sorry, I'm going to hold you to it.
Oh, no, absolutely. So I come from Canada. And naturally, I'm really interested and excited about the skiing. Very fortunate to be surrounded by amazing ski resorts there. And one of the problems that I faced is that, and a lot of my fellow skiers there share this, is that there isn't really good high-quality backcountry ski maps, and especially ones that share like real-time data on conditions and avalanche, and that's the you want to enjoy, but also you don't want to die enjoying the mountain. So in my free time, I started vibe coding an app for essentially making a crowdsourced real-time conditions map for backcountry skiing. And it's been, I've had the same experience. It's been phenomenal, and I'm blown away. I mean, I'm already in tech, designing products in AI, and I'm already blown away by how the degree of capability and how fast you can design new software. And to be honest, I'm a little bit worried because I'm enjoying it so much that I might actually spend my weekends instead of skiing, more vibe coding. So. Yes, I don't have this on my LinkedIn.
That's awesome. I'm an avid skier and snowboarder. It is on my LinkedIn. I live outside of Park City, so if you're ever out there, hit me up. But you'll have to get out there to kind of document that area and the conditions, because I would also like to not die when backcountry skiing. Anyways, we'll move a little further outside the Google ecosystem to multi-cloud with Colin. Do you want to tell us a little bit about you and Baseten?
Sure. So my name is Colin McGrath, and I run the infrastructure team at Baseten. Baseten is an inference as a service provider, and we are dealing with sort of the ability to scale and serve all of these LLMs performantly. In the past 90 days, a little fun fact about Baseten, we've scaled from 50 million inference requests a day to over 400 million, and it's not slowing down. So we get a really interesting front row seat to all of the interesting ways that everyone is using LLMs today. Baseten sort of stands on three key pillars. One is model performance. We spend a ton of time optimizing models, optimizing runtimes, and sort of figuring out how to give people the best possible performance without needing to trade usability or trade for what you can do inside your own company. We have teams that are dedicated to that. auto-scaling for cost, and then reliability is the really big one. So as we heard earlier, things fail. These GPUs get hot, they break, servers go down, clusters go down, sometimes even clouds go down. And we do distribute cross-cloud, cross-region, across many different chips, many different types of chips to make sure that everyone always has the best possible performance and has no downtime. So it's been a very exciting place to work. It's been a very exciting problem to solve. It's a huge pleasure to work in the inference space. And a fun fact about me, outside of work, I also like building, but I also like racing. So what I do a lot of is I do a lot of sensor fusion for racing to figure out how my setups and how I'm driving relate to each other and how to get the best possible performance, leveraging AI. So it's a lot of fun. Yeah, that's a bit about me.
Well, we have a lot of fast action sports up here.
Action sports and startups tend to
Yeah,
overlap.
it's
Yeah.
Got to keep that adrenaline high.
We do, yeah.
And somebody maybe to keep us safe and secure. We have Palo Alto Networks. Ram, do you want to give us a brief intro?
Yeah, so hi everybody. I'm Ram. I work at Palo Alto. I've been, before the Gen AI, I was mostly working on the traditional AI, ML kind of stuff, time series kind of analysis. Recently with Gen AI, like doing all of the Gen AI-based architectures and implementations in Palo. A little bit about Palo itself. We are a leading cybersecurity vendor, protecting enterprise users, endpoints, and workloads and applications. Fun fact about me, I'm an avid kind of a photographer. I do black and white, kind of darkroom still based photography. I've kind of tried to not use Adobe or Photoshop, but with the new Imagen and stuff like that, it's it's going to be interesting.
So you do actual like darkroom.
Yeah.
That's
an art.
That's an art.
Yeah.
That's
But
that's amazing.
with some of the things Imagen can do right now, it's pretty impressive. So.
We'll keep at it. So next, what we're going to go through is, Antonio, you alluded to this a little bit with Owl AI. You went from founding to these Summer X Games in less than 10 days. Now, I know we talked about adrenaline and keeping that high, and I think that gives me a little anxiety thinking through it, but how were you able to do that and build that in such a short time?
Not sleeping. We had a kind of like this running joke while we were at the X Games where it's like every time, look, nothing was like perfect, right? Like you have 10 days, like you're just hustling and you're doing all this stuff. We had this idea of like, oh, we need to print these shirts that just say like 10 days. Like it's only been 10 days to remind ourselves like we are 10 days in and we are doing this incredible thing. We were very fortunate that the chairman of our board is also the CEO of X Games, who's also an Olympic athlete and like former NFL. Like so he's like very connected and he knows like that world really well. And I think the interesting thing of like going from like 0 to 1 is that we had a lot to draw on from being, from working with Google and like understanding and knowing like how the cloud works and knowing that we didn't enter it as like, oh, we're fans of sports and we're just going to build this technology. We have no idea how the technology works. Like we knew what we were doing going into it. We had, between Josh and I, decades of like experience, right, of like build up through it. So we were able to like jump in and like, okay, we know, boom, what we're going to do, and how we're going to do it. And we had, preliminary judging and officiating of some of the sports, right, which is really interesting. We did a lot of translation as well, so accessibility to a lot of sports. You have this idea of translating sports to other nationalities, but it's not easy to do. Not everybody can afford it. Not everybody, and you think about how many languages are, right? Like hundreds of languages, right, around the world. And how do you do that at scale in near real time, coordinated, right, and doing all of that stuff? So those are all interesting challenges that we kind of like dove into, but just no sleep. That was it.
So how did you build it?
It was all built, obviously Google Cloud, right, coming off of it. We used a lot of pre-rolled LLMs and a lot of our own ML stuff that we threw together very, very quickly, that we did some light training on some accelerators, right, to get to where we need to be. Our version 1s were very rough, but all just written a lot of in-house work. Our version 2s are going to largely leverage TPUs going forward and take advantage of like the TensorFlow and TPU like network that's usable.
So I haven't seen a API on Vertex that judges and watches motocross or anything like that, skateboarding. So how did you train those on Vertex?
So a lot of it was, you're right that the data is in it. So the first thing we do is do the very naive approach, which is like, let's feed it to the LLM. Let's feed a video to the LLM. Let's see what it says, right? Let's just like, here's a video.
Somebody on Substack probably looked at it.
Yeah, correct. Yeah, we just like feed it in and just say like, hey, can you tell me how high this motorcycle jumped into the air? And it was like, well, I can give you like, if you tell me the point of reference, and it did okay, but it wasn't right, right? And when you're thinking about officiate, like you need to be right, right? Like that's kind of like the whole point. Yeah, hopefully. Well, that's the thing we're trying to fix, right? Is you need to be right. So one of the things that we ended up doing, and which we're still doing now, is we're taking like a lot of those things, we're clipping, the data out. We're essentially fine-tuning, right? We're fine-tuning on top of Vertex for the LLMs, and we have our own like fine-tuned concept, which we then can use to sort of like get the details out. And you think about, we have to do that for not just motorcycles, but we did it for like skateboards and for everything else, right? And like different formats for skateboard, because you have like vert, and then you have street, and you have park, and like there's different like. Park is like the one when you're in the big, like, it looks like a swimming pool, right? And vert is the one when you're on the ramp and it's going like this and back and forth. And street's the one when it looks like you're in like a, there's park benches and like you sliding along and you're a hoodlum doing things that you shouldn't be doing, but it's cool, right? So like judging all of those are different, and like how are people turning and how that. So all of that was just clipped, labeling, training on historical data, and then feeding it and growing it, right? And Vertex just made it like that.
Okay. And then where do you draw that line where you think you need to go to TPUs to be able to train your model?
I think when you start thinking about driving into TPUs, which is a big one, it's just cost per performance, right, and speed. I have the secret weapon, which is that
no sleep.
No sleep. Well, I'm blessed with I only need about 4 hours of sleep a night usually. So like, but then there's also that I just worked at Google for so long. Yeah. So like I know how to do it, and I know what happens when you do it the right way, right? Like I know like when you use TPUs and you do this, like you just get in this incredible performance and this incredible growth in a way that is difficult to compete with, in my opinion. So it's sort of like a no-brainer, right? Of our next evolution for the things that we're going to start training and tuning, both in vision and in audio and in like all these things, are all going to be TPU driven, because it's just going to give us the best performance. It's going to let us iterate the fastest. It's going to let us get the best results.
Well, fantastic.
Yeah.
So we'll move on to SandboxAQ. Arman, do you want to talk a little bit about how your end-to-end ingestion and how you manage all that data and train on it and what that looks like?
Yeah, absolutely. I mean, our use case is a little bit different, because in order to train these large quantitative models, we can't just scrape the web to get more data. We have to generate our own data, because these are physics-based simulations, which means that we have to start with a high-performance computing use case of cloud, where we are essentially tapping into tens of thousands, hundreds of thousands of compute resources, whether we are talking about GPUs, CPUs, TPUs, and to be able to orchestrate them for these parallel simulations. So we run these massive scale physics-based simulations in parallel on the cloud to generate synthetic data to begin with, which captures basically the dynamic interactions between molecules and small molecules and proteins, and understanding how they interact with each other and what the resulting phenomena and observables are, basically. So we need to generate that data. The data is very multimodal as well, because we deal with this like physics-based simulation data, but there's also data that we get from experimental assays. Like there's a wet lab chemist who's literally with glassware combining, compounds together and see whether it turns green or red, and they document these experimental data as well. But also there's data that comes from sensors and other forms of also visual data that we have sometimes from the biomarkers that we look at and phenotypes in the body. So it has a very multimodal nature, and it also comes from both experimental and synthetic sources. And for us, actually being able to manage all of this data, to be able to query it very efficiently, and to be able to combine it in a way that it is still reliable to the science behind it that is representing, the accuracy and the precision in modeling the science behind this becomes really important. And that's where a lot of the managed services that we have access to, like BigQuery and the GQE, basically the Kubernetes platform that allows us to scale, becomes really important to be able to, first of all, generate this data from first principles, combine it and curate it, and then that's where now we can start thinking about training the model, which on its own is very complex. And these are physics-based models. I think with transformers, we basically saw a revolution and a paradigm shift in AI. But at the same time, we are at the very beginning of this transformation. There's also changes and improvements to the underlying architecture that needs to happen, especially when we are, for example, looking at some of these diffusion models. When we want to go from generating creative images of cats and dogs to generating molecules that are going to cure brain cancer, then it becomes really important now to be able to essentially play with different architectures and to be able to look at different training paradigms, different AI architectures, and being able to use Vertex to look at this multitude of parameters and hyperparameters and different models and different architectures that we have to test and essentially see which one is working best for these purposes becomes really handy. And it saves our scientists and engineers a lot of time, not necessarily spending their time working on things that don't make our beer taste better, essentially, and focus on chemistry and focusing on basically training those models. So these managed services have been really helpful for us to be able to focus on that and to be able to train these models on that data.
I just want to say, making beer taste better is a noble cause.
I was going to agree with that.
So.
And then can you talk a little bit, you mentioned Vertex and how you're ingesting all this data too, and you're doing some training. Can you talk when you use Vertex via like Cloud Run versus batch, or how you make those design trade-offs?
Yeah, absolutely. So trade-offs, I feel like my job is every day like juggling these trade-offs as engineers. Yes, so particularly with these managed services, I mean, we are always looking at this trade-off between essentially flexibility and customizability and ease of use and ease of deployment and simplicity or complexity of deployment, basically. And at Sandbox, because we have this unique workflow that we go from generating our own data with HPC mode all the way to training and serving models, there are actually different places where like different components become more relevant. So for example, when we are doing data generation and we are in the HPC mode, we are essentially putting chemistry on the cloud for the first time. So we have to go back and re-engineer a lot of what we know about scientific computing on the cloud. And in those places, we actually benefit a lot from more customizability. And that's where we use, for example, Google Kubernetes engine. That gives us like maximum flexibility and customizability when we want to really design a cloud-native version of our workflow and to really get maximum juice out of like millions of compute resources that we scale up and we use for that. But then as we move on a little bit later in the process, like training and then eventually serving those models, when we don't need that much flexibility, we don't need that much customizability, the resulting models in a lot of cases for these LQMs, even though they are large in nature, but they are actually significantly smaller than LLMs with like tens of billions of parameters or maybe closing to hundreds and trillions. We are talking about a smaller model. So when we reach that point, we actually don't need a lot of fancy customizability. We can use we can offload a lot of our work on more managed services like Vertex AI that has made it a lot easier for us to do basically looking at multiple models deployed, benchmarking them against each other, and really understanding which one is performing better. So we have been really dealing with these trade-offs and design choices throughout this process because of this end-to-end pipeline. And I mean, another trade-off point that I can give you an example of is when we want to design a new drug, we often start by essentially screening a massive data set, like tens of billions, hundreds of billions of molecular compounds, because it's really a needle in the haystack problem, right? You want to find that one particular molecule that works really best for that target disease in terms of being efficacious and having high potency, but also not being toxic. You don't want it to solve the problem, but create 10,000 other problems, you know what I mean? So it's really a needle in the haystack problem, and we have to screen these massive data sets, which means that we have to do like millions of parallel, sometimes embarrassingly parallel simulation, HPC simulation workflows, which is basically, it's easy to scale them up when you are using batch and auto-scaling mode, for example. But there's always this trade-off between scaling and cost. Because if you are doing it naively, then you could rack up a huge, basically, cloud bill. Whereas if you are getting into the details of this and understanding the nuances of this, then you can really optimize how you are leveraging that auto-scaling, on which resources, get into the nitty-gritty of like the design choices that you need to make in your workflow. We had to create our own custom queuing framework or load balancing framework. And through that, we were able to hit more than 95% utilization, for example, on our GPU workflows, which our NVIDIA friends tell us that is an impressive outcome. But really, without that, there's always this trade-off between scalability and cost. And I think once we get into understanding what it takes to have cloud native deployment, then you can design and get the optimal response that you want from it.
Well, hopefully that didn't resonate with anybody. Then everybody lives in an ideal world where you don't have to make daily trade-offs. So, but if not, hopefully you were able to take something from that. Colin, I envision that Baseten helps provide that ideal world for users. Can you talk a little bit about how Google Cloud and maybe how like Dynamic Workload Scheduler helps you enable that ideal world for customers?
Yeah, absolutely. So at Baseten, to give you guys a bit of background, we built this system that we call MCM, which allows us to treat all of our compute across the world as one large global pool. And what that allows us to do is that allows us to get high utilization across the world and make scheduling decisions, placing these models as close as possible to our end users, and then distributing that work across the world while taking into account security, while taking into account compliance, and making sure that's all set up properly. And DWS in particular helps us with the reliability story of MCM. We do see all sorts of failures. We see failures across the stack, all the way down from the chips all the way up to whole regions going dark for certain periods of time. And on more than one occasion, DWS has saved us in that we were able to scale up compute in a flexible way very quickly in under 10 minutes. And then immediately through the system that we built, in an automated way, shift all these workloads that are having an outage to DWS. And in under 10 minutes, everyone comes back, right? Which is, it's very impressive when we do have a P0 or an outage, and we get paged and we go look, and everyone's back and healthy, and we're like, oh, this is amazing. So that would not be possible without a system like DWS. Oh. And it has really been like the backbone and safety net for us to run our business.
That's great to hear, especially on the flexible consumption, being able to help you get those resources. But how has Google Cloud enabled your multi-cloud strategy?
Yeah, so like I talked about, Google Cloud, in terms of DWS, gives us that flexible pool of compute. But we also have this idea of tiered computing layers, where we have dedicated compute. We have more flexible compute than the maximum flexible compute, which is DWS. And Google provides all of those different layers of flexibility that allows us to build these stable and scalable systems across the world in all of our regions at all times. Specifically, like with reserve capacity, one of the really nice features of Google is that you can share the reservations, right? So you can have the reservation in one place, but you can move those GPUs around as needed into different regions and into different projects. And that allows us to always be where our customers are.
Well, very nice. And one thing we had spoken about is the cluster level isolation. How do you build that out?
Yeah, so for our customers, especially for enterprise customers, security and AI is very, very important. There are many different ways you can build security in AI infrastructure. There is kernel level isolation in terms of micro VMs, Kata containers, different ways to get isolation at the GPU level. There is node level isolation. There is cluster level or VPC level isolation, and there's like full air gapped isolation. And what Google allows us to do is allows us to leverage things like private service connect to set up very strict security rules into isolated locations for our customers while leveraging DWS and this shared reservations to move capacity in and out, so our customers don't have to go think about reservations and shared capacity. We just sort of manage that all for them. And then provide all the security requirements of a single tenant isolated VPC running in multiple locations in multiple regions that can split these workloads all over the world. And without Google and without things like Private Service Connect and all the VPC abstractions you guys build, it would not be possible.
Well, I think the numbers kind of speak for themselves in the slide that you're able to, well, one, get such an increase in performance when you use the latest generation of chips, and then also the price per latency when you're serving too. So
yeah, of course.
Yeah.
Yeah, and just to add to that, in order to keep the price down, in order to give people A, the scalability, and B, the cost optimization, systems like MCM, and be able to go into DWS, which might be a little more expensive due to its flexibility, but also lock into longer term reservations and cheaper compute allows us to give very, very competitive pricing while maintaining all the flexibility of a sort of serverless environment.
Great. And then Ram, we'll talk a little bit more about Palo Alto. Now, Palo Alto uses a broad range of Google products, and your team is entirely focused on building out agentic experiences. Can you talk a little bit about that?
Yeah, so we have like 3 main personas we try to address with that, right? One is our sales engineers. We want to equip them with the best knowledge they can get from all of our internal technical documentation. They're able to do role plays. So we had one interesting experience where we had a fresh sales engineer join the team. They went through this agentic experience, and within 72 hours, they were able to close the deal, right? So previously, that takes much longer, right? So that is kind of one part of the story, right? The other one is these sales engineers are not very techy, right? So we want to give them like all the information they can get right on their Slack channel. So they have a personal bot. They can just chat with it, whatever information they need. They're ready to solve customer problems, right? On the other hand, we have our support engineers, right? So they get a lot of cases, and sometimes cases are easy, sometimes cases are complex. It used to take a long time before to solve some of these. With some of these agentic workflows, we are able to reduce our TTR by almost 50%, right? So, and we are trying to solve more complex problems now with using tools and ADK and all of that stuff, right? Similarly, for our customers, when in the traditional world, if they have to get access to data, they used to go through our product managers, ask for requirements. We used to build dashboards. Now we introduce Canvas as a way for them to explore the data, right? So they can do, if they want to do threat hunting, they can do it themselves. They don't have to come to us for creating a new widget or a dashboard or some other thing, right? So some of these are incredibly helped kind of self-serve themselves, so they're unblocked and much happier customers.
So one of the trade-offs you mentioned to me was the consistency and real-time evaluation. How are you able to manage that at scale across your company?
Yeah, so real-time evaluation is kind of a harder problem because post something, if you have the ground truth, you can evaluate how good or bad it was, right? So some of the things we are looking at is the data coming out of the models, like the log probabilities, to see, hey, what is the confidence of this answer, right? Especially when you're dealing with RAG. And the other part of the system, when we do like NL to SQL, right? how do you know the SQL you generated is actually semantically correct, right? It's syntactically to be correct, but semantically it could be wrong, right? So there we have tried approaches where we kind of go back from SQL to the user query and see, hey, is there a semantic consistency between these two, right? So, and consistency with the newer thinking models has been a challenge. I don't think we have fully solved it. We're trying some fine-tuning approaches. We'll see how it goes. So,
Well, Antonio, I'm going to ask you really quick because in the X Games, you're kind of doing things on the spot and you want consistency in your judging. How do you manage that trade-off?
So we actually, what we've ended up doing is one of the biggest mistakes that I think that you can do in this space is get one response and wait for it to come back. We actually launch multiple, at the same time. And then we look for discrepancies, right? So we have like this concept of like what we're looking for and where the discrepancies are. And then we have strategies. So you can apply different strategies. Depending on how well you can average, right? So like just simple averaging, right? You can like cut out outliers. Like it's just the idea is that you shouldn't just be using a case where I'm querying the model once, I'm going back, you really need to do this in parallel across multiple times. The other thing that you really want to do is try to be a little bit more in the spirit of being agentic. Like you want much more specific workflows for the same data. So like if somebody if there's some chunk of data, but there are multiple different outcomes or there's multiple different things that you want to extract from it, you want to do that embarrassingly parallel, right? Like you want to do that in a parallel way where you can have multiple agents look at the same data and extract different value out of each one simultaneously at the same time. And that helps you mitigate a lot of the concerns around consistency because then you can take those learnings, those group learnings, and then derive value from that, right? So.
Well, very interesting. Different use case. Did I lose my mic? Oh.
No, there it is.
So Ram, we'll also go back to what you're doing at Palo Alto. What are some of the technical trade-offs that you've had to make in building out these agentic experiences?
yeah, I think in the previous talks they were talking about we get queries that are short, like search queries. Still, people are not used to this agentic experiences, right? So you get short queries. Then you get really long queries, which are like multi-intent, requires complex thinking, all of that, right? So how do you balance the trade-off of latency versus, when do you want to think more, when do you want to, get right to the answer, right? So those are some of the trade-offs. Like we've tried different approaches with some level of classifications to figure out when do we go into a thinking approach versus traditional approaches and things like that. So that is one of the few options we've done.
Okay, very nice.
Yeah.
Now I'm going to open it up to everybody. What are you most excited for, or what's next for your company to build?
Ooh. I talk a lot. Sorry, does anyone, okay.
I can go next.
Go.
I'm most excited about agent space. I think that's really exciting, especially agentic AI frameworks for computational chemistry is super interesting because, as I said, I described this virtual screening process, and there's a lot of experts that they have to spend time just looking at molecules and make decisions just because we didn't have models that could reason before and make decisions about like using different tools. So there's tremendous opportunity to accelerate drug discovery by being able to introduce agentic framework on top of what I described earlier, and I'm super excited about it. And agent space on Google Cloud is making it super easy to be able to experiment with different types of personas, different types of agents, and that's what I'm super excited about. And we are already building something. It's in the works, but it's going to come out hopefully toward the end of the year.
Well, we can't wait to see what that is. Colin, Ram, do you have something you're excited
I'll
about?
share a couple things. So for us, there's a few really exciting things that we're working on. One is bringing KV cache-aware routing and disaggregated serving as sort of a first-class citizen in our product, which is very exciting. We can do a lot of very cool things internally at the company with it, and we're excited to bring that to other people as well. And then the second thing is with the RMAI paper and sort of exceptionally fast cold starts over InfiniBand networks. So how do you bring up a DeepSeek, for example, which is over 700 gigs of weights in under a minute or even under 30 seconds, so that you can have maximum utilization and cost efficiency. So we're building things there as well, which are very, very exciting.
And then Ram, you have 30 seconds.
Okay. So we want to make sure that our customers' journey through either when they're using the products or when they have trouble with the products, they can help them so fast, right? So we want to get to an experience where they're able to self-serve like 90% themselves. That's what we're excited about, right? So.
Well, fantastic. Well, thank you all so much for joining me. I really enjoyed it. And I'll hand it back to Mark to be able to walk through some of the closing announcements, and then we'll kind of move on to lunch. So thank you.
Thank you.